Hello, here are all the constructions you can do with a perpendicular bisector. Let's start by drawing a line here, and then I'm going to do a perpendicular bisector. But I'm going to be very strategic about where I place my perpendicular bisector. My compass is currently set to this width. I didn't really care what width it was, but I'd like to make, when I build this perpendicular bisector, I would like to not perpendicularly bisect this line that I started with. I kind of just want to perpendicularly bisect just this section. The reason I'm doing that is because I would like my compass to be the same width as the line that I started with. And so you can see that these endpoints touch those circles. And when I do that, what I create is an equilateral triangle, not just an isosceles triangle, an equilateral triangle. So this is a radius of the circle, and this is the same size circle. So those radii are equal. But remember, I chopped off this line so that this piece is equal to. So I created an equilateral triangle. If you're wondering where that perpendicular bisector is, it's right here. It's been here the whole time. I just didn't necessarily need to draw it because I wanted to draw a perpendicular or an equilateral triangle. But everything that we create with a perpendicular bisector, it's not just the perpendicular bisector. We can do an equilateral triangle up here. If I want to, I can place my compass here in the middle, and I'll make this line the same length as this line. I'll make it nice and large so that nothing gets in the way here. So you can see it. I'm going to go ahead and go circle all the way around. You'll notice when I make a circle that I put my compass point down and I spin the paper. I hold my pencil like a pen, or my point like a pencil, and I spin the paper. And so what I've done here is, if I ignore this section, and I ignore this section, and I ignore this section, and I extend this section like that, then I have from here to here, and from here to here, and from here. I've built an isosceles triangle and an isosceles triangle. So all of these lengths are the same. So it's a rhombus, but not only is it a rhombus, but the diagonals are also intersecting in at 90 degrees, but they're equal to each other. So I created a square. That's what a square looks like. You just do a perpendicular bisector, and then you cut these all in half. Or you do a circle all the way around, and not cut them in half, you cut them off, is what I meant to say. At the circle, so draw a circle all the way around, and your diagonals are, now you have a square. If I wanted to, I could just connect this down to here, and this was my equilateral triangle, if you recall, just like that. And if now I have a little rhombus, it's not a square, but it's a rhombus. Rhombus are also pretty nice. If I reset my compass to this original length and I finish the circle all the way over here. So that circle that I originally drew intersects this line here. If I do one more, then I can connect. I'll do it in a different color. I can go here to here to here, there, to here, there, there. And now you have a hexagon. That's an equilateral triangle, and then another perpendicular bisector. You can't see the bisector part because that wasn't what was important, but there it is. Another one over there. Oh my goodness, and look at this, I just created a rectangle, which means these sides are parallel to each other, and these sides are parallel to each other, and these are parallel to each other, and these are parallel to each other, So all sorts of different shapes here that are equal to each other. If I wanted to, I suppose I could copy this angle right here somewhere else. So I'll go ahead and just copy it down here. So I set my compass to be this width. So I'm going to draw the same size over here, like that. The way you copy an angle is you draw that circle around and touch the two sides of your angle, and then you measure how far apart they are. Once you have that measured, you just copy that over here on the other angle, point here, and I can connect from here to here, and I copied that angle. And what was cool about that angle is it was 90 degrees. So now I have a 90-degree angle over here. And if I wanted to, I could cut this angle in half. And now I have a 22.5-degree or a 45-degree angle. And if I wanted to, I could cut that one in half. Oh, almost off my page here. My compass is a little large. And now I have a 22.5-degree angle. And since I'm cutting angles in half, I might as well cut one of these 60-degree angles in half. Where's my equilateral triangle? Right here. I'm going to cut that one in half. Oh, I already did cut it in half. It's 30 degrees right there. And if I wanted to cut that one in half, then I draw a little circle around it, like that. And cut here and here. Pass on through. Now I have a 15-degree angle. Anyway, those are all the constructions I can think of that you can do with a perpendicular bisector. The point of working with a compass is it's a tool that can save lengths of lines that be the same lengths. And if you have that ability, then you can just construct so many different shapes.